Hello, calculus fans. All right, in calculus 1, we define the area A under the curve y equals f of x and above the x-axis between x equals a and x equals b, where f of x is a non-negative function, be this integral. So this integral gives us the area under the curve. So the integral from a to b of f of x dx. Let's look at a picture of what we're talking about. All right, here's a typical situation. We're just going to compute the area under the curve. The integral computes this. And this is a very powerful thing. It allows us to compute the area of objects that are not polygons or circles or ellipses or sectors of these things. This is really a big deal. Now let's suppose that we have continuous functions f of x and g of x with f of x bigger than g of x, at least on some interval from a to b. Then we're going to say that the area between these curves is the integral from a to b of f of x minus g of x dx. Now here's a picture of this situation. Okay, so we have a curve y equals f of x and another curve y equals g of x. We're computing the area between them. It doesn't matter that the functions may be above or below the x-axis. That doesn't matter. What matters is that f of x always stays above g of x. So it's not necessary for these functions to be positive, but we do want f of x to be bigger than g of x, at least on the interval that we're interested in. Okay, that's all for now.